Volumetric analysis involves measuring the volumes of solutions involved in chemical reactions. One such way is through titrations, in which a sufficient volume of a solution of a known concentration is added to completely react with the substance being analyzed. For example, vinegar. Now, vinegar usually contains between 4 to 5% acetic acid. This is equivalent to an acetic acid concentration of between 0.67 and 0.83 moles per liter. So let's say the bottle claims these figures, but you just want to make sure that they're not lying. So, the exact acetic acid concentration can be determined by reacting it with sodium hydroxide solution of a known concentration, like the exact amount of moles per liter of it to multiple sig figs. Like if you ordered hot chocolate, you'll know the exact amount of granules per liter of milk. Anyways, from the volume of sodium hydroxide solution needed to neutralize the vinegar, the concentration of acetic acid can be calculated using stoichiometric calculations. The point at which chemically equivalent amounts of acid and base have been added is called the equivalence point. This is when the ratio of moles of acid and base that have been added is the same as the mole ratio in the balance equation. So in the titration of sodium hydroxide solution with vinegar solution, the equivalence point occurs when the number of moles of sodium hydroxide is added equals the number of moles of acetic acid that was present in the vinegar. So if we took 5 mils of a sample of commercial vinegar and it was completely neutralized by, say, 24.5 mils of 0.15 moles per liter of sodium hydroxide solution, what would be the acetic acid concentration of the vinegar? Here's a balance equation. Ignore sodium since it's a spectator ion. Calculate the number of sodium hydroxide moles used to neutralize the acetic acid. Convert that to moles of acetic acid neutralized. Then we can use the moles to work out the acetic acid concentration using C equals N on V, and then solve for C. How do we visually know when we've neutralized it? We'll save that for another video.